So today let's start conic section. The first part of conic section is parabola. You know perhaps. Uh, just write. I need to write this. So before starting with the definition, just understand the thing. Suppose let us consider a fixed line like this, and we are saying that the equation of that fixed line is this. Suppose our axis is there, this is the axis, and a variable point P is taken outside the axis. So let us say let the variable point is variable, or it is also called a moving point, right? If we see the perpendicular distance from P to that fixed line is same as the, let us consider a fixed point S, which will be called as focus. If that distance is equal, then we will say that the locus of that P is a parabola. Clear? Suppose this is M. If PS equals to PM, then locus of P is a parabola. Clear? So if for a normal conic section in general the ratio of that PS over PM is called the eccentricity. In parabola the E value is 1, right? In parabola it is E value is 1. So what will be the value of PS? You know that PS as per distance formula will be like this. And what is the value of PM? We know that external point P, and we can write the distance formula from the straight line concept, that is PM will be AX plus BY plus C over root A square plus B square. For a normal general in general conic section, what I will say, PS equals to EPM, that is this equals to EPM. Right? So to remove the root over sign, what we normally do, we normally square both sides and it will become E square, and this will become square, and this root will vanish and it will become A square plus B square. This equation is the normal equation for any conic section, right? If E equals to 1, then it is parabola. I think that it is clear, and in the next part we will be discussing some other things. Let me go for a new note. Okay, so in this part what we will do, we will write a general secondary equation. I have written in case of circle, you know that the general secondary equation is this. you know perhaps x square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. It is the general equation of second degree. From here I will get some conditions, and that condition is very much necessary in doing in identifying that whether it is a parabola or it is a ellipse or it is a circle or it is a rectangular hyperbola or it is a straight line, like this, right? I should write a specific form del, and I have told you perhaps del in some previous lecture. It will be written in this manner: HGF. This determinant value we need to find. Say for some case 1 I am writing. For first case, if del equals to 0, then you are confirmed that it is a straight line, right? From there we should find first if h square minus ab greater than 0, then I will get two real distinct straight lines, right? In the second case, if I find equals to 0, then real coincident, both will coincide, that is, we will get a one equation. And if it is less than 0, then we know that this is imaginary line we will get. Now this other case is, suppose the value of the del not equal to 0, then what will be the, if the value of del not equals to 0, we need to further investigate some part, that is the value of h square minus ab from the second degree equation, right? Any equation can be written in the form, any conic section can be written in the second degree form, that is, you will not find the exact form of that circle or exact what we are doing. We can get this type of form. So from here you can understand, we have to understand. So if that h square minus value is 0, then it is a parabola, right? These are the conditions, okay? And the second is, if it is less than 0, it will be ellipse, clear? And if it is greater than 0, it is hyperbola. I will give in later classes I will discuss ellipse, hyperbola, rectangular hyperbola, like that. If this is greater than 0 and another condition is imposed, that is a plus b equals to 0, then it is rectangular hyperbola, right? And the third part is that if a equals to b, h equals to 0, I have told you this is condition for circle, clear? So how to get conic sections? Suppose let us take a figure. Just like say two cones having a common vertex, clear? If suppose this is the axis, if it is cut like this, right, then what we are going to get, we are going to get a circle. This will be a circle. In another case, if suppose we are cutting in this manner, right, then what I will get? I will get a hyperbola like this, right? If these are all the planes we are cutting, right? If this same plane is tilted, suppose it is tilted at an angle theta, that is, it is down like this, like this. If it is tilted at an angle theta, then we will get ellipse, right? And if the last one, how to get parabola? Taking the lower part, that is one cone, if we cut the plane of that cone like this, we are going to get a parabola like this. These are the way of getting different type of conic sections, right? Now let us come to the equation of different types of parabola. So now let us give some idea about the equations. So as we know that a parabola, I have told in the initial case that is a fixed line, that is called directrix, that fixed line ax plus by plus c. Suppose the fixed line has a equation x plus a equals to 0 and a parabola is passing through origin like this. Clear? That is, vertex of the parabola is 0 0, and s I have told that is also that is called focus, that fixed point, right? And p is the point on the parabola. Actually, if the focus will be x0 a0, right? Let us consider a point p, and let us consider a point p is there, xy. Okay, this is lying on the parabola. Clear? Now one thing, the chord passing through that focus is called Foucault chord. Okay, and one thing, if this is double ordinate, if it is a double ordinate passing through the focus, then we will be telling that it is a latus rectum, right? This is directrix, I have told. This is latus rectum. So I have told that SP, suppose let us consider the point on that fixed line is M. Same. What we normally do, we do the same thing, that is root x minus a whole square plus y minus b whole square, that is PS equals to EPM. EPM means mod x plus a over root 1 square. So if we square 0, sorry, this will not be the a0, we will get e square x plus a whole square. If we simplify this, what we are going to get? We are going to get a simple equation, that is y square equals to 4ax. So what we will say, vertex of this parabola is 0 0, focus s a0, length of latus rectum, this length ll dash, length of latus rectum is always equals to 4a. Clear? This part, this is the length. So ls and sl, ls equals to sl dash always, and this equals to 2a. So if coordinates are told that what will be the coordinate of the latus rectum, then L will be on the first quadrant, then you will write a 2a, L dash will be a minus 2a. Clear? This is the extremities of latus rectum. And what is the focal distance? Focal distance is x plus a. Focal distance is x plus a. This ls, like this. ls means ps, okay? ps. And equation of the axis is y equals to 0, and equation of the directrix I have told x plus a equals to 0. From here we'll go to another part, that is, if the parabola is just symmetric but in opposite direction, like this, then we'll see that the equation becomes y square to minus 4x. Clear? Just what happens, focus goes on the left side, so fs will be minus a0. Length of latus rectum will not change, and the extremities of that latus rectum, like this, the extremities, this part and this part will just change, and we will say it is minus a 2a and minus a minus 2a, and the equation of the directrix will come here, that is x minus a equals to 0. Clear? This is the equation of the directrix. Vertex remains same because it is also parabola is passing through the origin, so vertex is 0 0. There is no change in vertex. And then other two parts are also there, right? The other two parts are, let me write, one is x square equals to 4ay, x square equals to 4ay, that is, you will see that the parabola passing through the origin, but like this. For here you will see that directrix is lying here, that is y plus a equals to 0. Axis equation of axis, if we write, what will be, x equals to 0. The length of latus rectum will not change. Length, suppose it is L dash, L length of latus rectum L dash equals to, suppose, the same, that is 4a. What will be the extremities? Extremities will be, this is 2a, x value, it will just change 2a, this point, and minus 2a, L and L dash, the extremities. And what will be the focus? The equation of focus will lie on y-axis, that is 0a. I think it is clear. Vertex don't change. Vertex will remain same, that is 0 0. Another form is there, that is called x square equals to minus 4ay. Just it will go lower, like this. Picture is quite bad, I know, but I think that it is clear. So here it will be the directrix will go upper, then it will be y minus a equals to 0, y equals to a. Clear? Nothing will change, only equation of directrix will change, and the extremities will here change. Here it will be 2a minus a. Clear? 2a minus a, and this minus 2a minus a. This point is this, and this point is this. Clear? This is the extremities of latus rectum. Length remains same, that this length will be 4a, right? Now let's come to the another part, that is we need to see whether the point lies inside the parabola or outside the parabola. If let us consider the parabola equation is y square equal to 4ax and a point P x1 y1 value is given, and we need to see whether P lies inside, outside, or on the parabola. On the parabola, if we see the value is less than 0, then obviously it is inside. Clear? If it is greater than 0, then it will be outside. If it is equals to 0, that is, it is satisfying. That means it is lying inside, it is lying on the parabola, right? If the point lies on the parabola, then it must satisfy this equation, that this y square minus 4a x1 will be 0, right? Now let us consider one parabola that is not passing through vertex. Then what will be the condition? Let us say like this, and let us consider like this. If the point, this is alpha beta, let us consider point on the parabola is xy, and this point is hk. This will be like this. I have done something wrong. It is neither, the point is neither lying on y-axis, neither on x-axis, the vertex. Then we will see some change. The change will be, it will be, instead of y square, we will write y minus k square will be equals to 4a into x minus h, right? Vertex will become hk, right? Hk vertex. Focus will become, for this we know that a0, then just add a and k plus 0. Focus. For the equation of directrix, what we normally do? We normally do x minus a equals to 0, then it will be like this, x minus h plus a equals to 0. X plus a equals to 0, we write. So we'll write like this, because h is there. It got the vertex got deviated, right? So what will be the equation of tangent at the vertex? The equation of tangent at the vertex will be, here not will be x equals to 0, but rather this part is equals to 0, that is x minus h equals to 0. Equation of tangent at vertex, right? And we know the length of latus rectum do not change, and this is also, this equation y minus k equals to 0 is the axis equation. Clear? I hope this part is clear. And then in next part, let me start with another set of example. Suppose a quadratic equation is given. I need to write in the form of y square equals to 4ax form, or y square equals standard form. That is, those are the standard forms. So to write this, what we normally do, we take this like this, or y minus c, a we normally write in the whole square form, writing the in the whole square form, or y minus c equals to a x plus b over 2a whole square minus b over 2a whole square, a into b square by 4a square. If it comes on the left hand side, we will see like this, a x plus b over 2a whole square, or x plus b over 2a whole square equals to 1 by a times y minus c plus b square over 4a. See, x square equals to 4ay, in the x square equals to 4ay form. Y is this, that is x capital X square equal to 4 capital A into y, right? Here 4 capital A is 1 by a, x equals to x plus b by 2a, y equals to y minus c plus b square over 4a. Vertex will be, what we do, x equals to 0, y equals to 0, we will get the vertex. And if we do the part, then what we are going to get, let me write, vertex will be, if x equal to 0, x equals to 0, capital X, then x will be minus b over 2a, small x, and small y will be minus b square minus 4a over 4a. Clear? And if focus, we have to do the focus. What is focus? X equals to 0 we put, and y equals to a for this form. And what I will get, focus is minus b over 2a, 1 minus b square plus 4ac, put y equals to a here, y equals to a here, we will get the value of y will be 1 minus b square by plus 4ac over 4a. This is the focus equation. What is the equation of axis? We know that the equation of axis is done by small x equals to 0 in case of this equation, but now I am writing in capital X form, then that it will be capital X equals to 0, that is capital X means x plus b over 2a equals to 0. This is the axis. What is the equation of directrix? We write y plus a equals to 0 for this type of equation, but instead of small x we are writing capital X here because small x is within this domain. So we have to change capital Y with the small y, and we are going to get a big equation. I am not writing, just I am writing y minus c plus b square over 4a plus a equals to 0. What will be the equation of tangent of the vertex? Capital Y equals to 0. We know. Just put that capital Y, this part, you will get equals to 0. Then you will get the tangent of the vertex. What is the length of the latus rectum? Now the question is, what is the length of the latus rectum? That is 4a. 4a is the length of the latus rectum. Length. Here 4a equals to, see, just getting 1 by a. That means 4a is the 1 by a, that is length is 1 by a. Length of latus rectum. Latus rectum. Clear? We are not getting vertex exactly at origin. If we are not getting that, then how to do? You should understand. What is latus rectum? You can also say latus rectum is a length of perpendicular focal chord. Focal chord which is perpendicular, right? If it is then suppose this is the equation, focal chord which is perpendicular. This is the latus rectum, right? It is also a focal chord. I need to better say. So let us start right now with the parametric coordinates. So for the parametric coordinates, we are getting 4 equations like this. For this, the parametric coordinate is 80 square 280, right? For y square. For this, we will get minus 80 square 280. T is being variable. T is the variable parameter, right? For this, you will get just opposite 280 80 square. For this, we are going to get 280 minus 80 square. These are all the parametric coordinate. Clear? Now let us do some thing that will make you clear about the focal chord, right? Just let me do. After that I will write the headline or the title what I am doing. Suppose 2 points on the parabola is given, that is passing the line passing through the focus, that is A0, and the 2 points are written in the form of parametric form. Then what will be the relationship between that T1 and T2? The question is this. If this is the question, what will be there? If PSSQ, then PQ are collinear. If they are collinear, PSQ, then I can write M of PS equals to M of SQ. If I can write like this, M of SQ is 282 minus 0 over 82 square minus A. If we simplify this, a special form will come, that is T1 T2 equals to minus 1. This is the most popular condition when 2 points are given, and that is a focal, the relationship between T1 and T2 of a focal chord, right? What is the length of the focal chord? Suppose if, wait a bit, if this is the parabola, let us consider this is the parabola, and the first point is AT square 280. As we know that T1 T2 equals to minus 1, this will be A over T square minus 2A over T. Then this distance is PQ. Suppose this is P, this is Q, right? And this is the S, What will be the PQ distance? You are going to get A T plus 1 by T whole square. Just if we do distance formula, you will get this. And if suppose the angle theta is given, this is the theta angle, then another form of that length of focal chord you are going to get, that is 4A cosec square theta, and this angle is theta, right? Clear? These are the length of focal chords. What is the length of semilatus rectum? You need to I will not say memorize, you need to note that. Okay, this is the 2 forms of length of focal chord, right? What will be the length of the semilatus rectum? This length of the semilatus rectum, that is you can say is 2A, because latus rectum whole length is 4A, and the length of semilateral rectangle will be half of that, that is 2a. It is equals to the harmonic mean of SP and SQ, that is the harmonic mean of the segments of focal chord. That is, we can write 2SP cross SQ, SP plus SQ. This is length of semilateral rectum. This is the harmonic mean. You need to remember this one. I can discuss in detail, but this has no importance actually. So I am just going through some important notes which you need to understand, as well as minutely do the problem when you need. Suppose another problem is there. This is the parabola. Suppose if the parabola, suppose we are drawing a focal chord, suppose this PQS. If we draw a circle considering PS as the diameter, okay, then it will touch the tangent at the vertex, that is, it will touch the y-axis. If we draw a circle considering PS as the diameter, right? If we consider PS as the diameter, suppose this is A0, this is 80 square to 80, then we know that what is the equation of circle in diameter from x minus 80 square, x minus a, y minus 280, y minus 0 equals to 0. If it lies on the y-axis, that is tangent of the at the vertex, then x equals to 0, 0 comma, let us consider k is the point. Then put in that circle equation, put x equals to 0, y equals to k. What you are going to get? You are going to get, suppose 0 minus 80 square, 0 minus a plus k minus 280, k equals to 0. You are going to get k equals to 80. That is, this point of contact is 0, 80. I am saying again the point. If we draw a circle considering PS, that is the segment of the focal chord, as a diameter, then the circle will touch the tangent at the vertex. Tangent at the vertex means the y-axis. The tangent at the vertex, tangent at the vertex of the parabola is the y-axis. That is, the circle will just intersect at a point, right? That point of contact is 0, 80. Clear? This is the most important part. Okay, now let us consider the part is line and a parabola. Line and parabola. Suppose a parabola is there like this, and we are drawing a line y equals to mx plus c. Okay, and this is a parabola. Let us consider this is y square equals to 4ax. If y square equals to 4x, putting the value of y equal to mx plus c whole square equals to 4ax, suppose we are going to simplify, then we will get like this. Okay, if we take on the right side, left side, we are going to get like this. Now let us consider this is the quadratic equation in x. So if we find the discriminant, what we are going to get? Suppose this is the discriminant, and if we simplify, we will get like this. Clear? If the discriminant is greater than 0, then there will be two real roots. That is, the d greater than 0, then it will be like this. This is the parabola, this is the line. Okay, if d equals to 0, that is we are going to get a tangent, that is it passes through a single point. For d equals to 0, that is a minus mc equals to 0, c equals to a over m. This condition is for tangent, that is that equation of tangent will be y equal to mx plus, instead of c we have to write a over m. Clear? And if it is less than 0, if d is less than 0, you will see that it is outside like this. Clear? So this y equals to mx plus a over m is the slope form. Okay, I am writing slope form of tangent to the parabola. Now let us consider some other equation of tangents that would give a better idea. What is the equation of tangent in point form? So what is point form? Point form is a basic form, that is y equal to y. We are just going to differentiate. Let us consider p lying on the parabola is x1 y1. If we differentiate with respect to x, we will get this, and dy over dx equals to 2a over y. Dy over dx at that specific point will get 2a over y1. Then what will be the, just write in point form of the straight line form. If I write, you will get y minus y1 2a over y1 x minus x1. If we simplify this, you are going to putting y1 square equal to 4a x1 in the middle. Okay, in the middle you will get this y1 square. This y1 square will be written in 4a x1. Okay, you are going to get y1 equals to 2a x plus x1. I hope this is clear. Okay, clear. So if I write this is the form, that is y square is changing to y1, x square is changing to x1, like that. 2x is changing to x plus x1, 2y is changing to y plus y1. Clear? So if I write in the parametric form, then I will get y1 is written in the form of 280. Clear? 280. And this x1 will be written in the form of x plus a of 80 square. We know that point is 80 square, 280, the parametric point. Then from here you are going to get another form, that is dy equal to x plus 80 square. This is another form, parametric form of tangent. This is also very important, right? And I have told the slope form, that is y equals to mx plus a over m. This is also very important in tangent, in solving different type of problems. Clear? If the vertex is not at 0 0, suppose vertex is at hk, okay, then just instead of y you write y minus k, and instead of x you write x minus h. Just this is the difference. Now let us start with the pair of tangents. I have told in circle nothing difference is there here. In circle I have told that suppose this is the suppose this is the point is not lying here actually. Point, let us consider this is the point. Let the point is x1 y1, that is the two pairs of tangent that are intersecting at a point x1 y1. Then what I am going to write if y square equals to 4x is the equation, the same form, that is s1 equals to t square. What is s? That is y square minus 4ax. What is s1? y1 square minus 4ax1. And what is t? y1 minus 2ax plus x1, that is whole square. s1 equals to t square. T means the tangent equation, whole square. This is the pair of tangents we have done in circle. Actually there's nothing to go more inside here. If the point from that tangent is drawn is, suppose 81 square 281 and 82 square 282, suppose the parametric form is given, then what will be the external point, that is intersection? That intersection you need to note it on your mind. That is, the first part is geometric mean of x coordinate and arithmetic mean of y coordinate. That is equals, that is geometric mean of x coordinate means root 81 square 82 square, and arithmetic mean of y coordinate means 281 plus 282 over 2. That is the point where the external point where the two pair of tangents, where the pair of tangents is intersecting, that coordinate will be like this. First one is geometric mean of x coordinate and second one is arithmetic mean of y coordinate. Now let us consider some other properties of tangents. You need to also go through that. The other properties is, suppose we are drawing a parabola like this and a tangent that is passing. If this is the focus, if we draw a line from the focus, and if the point is lying on y-axis, suppose, then suppose this is the tangent, okay, PQ, and this is the focus. If we draw from focus to the tangent point where it is intersecting on y-axis, this is always perpendicular. That is PQ perpendicular to PQS always. That is QS always perpendicular to the tangent. This is the another property, second property. What is the third property? Note it, make it clear. If you can't clear in the first time, then see it again, the video, right? Suppose this is the directrix and this is the parabola. Suppose this is a tangent. Tangent is intersecting the directrix at, suppose, Q, and P gives the tangent. This is, suppose, S, that is let us consider the focus. If we draw PS and QS, the angle formed by the PS and QS, this angle is always 90 degree. Okay, Q is the intersecting point of the tangent and the directrix. So if PS and QS is intersecting at that S point, then it must be perpendicular. That is the words. In words, if I write, it may make you quite hazy, unclear, but still I am writing. That is the portion of tangent to a parabola cutoff between directrix and the curve subtend right angle at focus. Clear? Now just a small part is there, that is parabola, you know, and in parabola if I discuss, no problem, it may take in 1 hour 20 minutes, I think it will complete. Okay, let us start with the normal. So in case of normal, you know that if this is the tangent, then this is the normal, this is the normal. Clear? It is not to you. If you have to do the normal, in the tangent equation you have got, for this we have got dy over dx at x1 y1, that is at the point is y1 over 2a over y1 for the tangent. For the normal it will be minus y1 over 2a. So if we write the equation in slope form, it will be like this: y minus y1, this is m, x minus x1, this is the slope form of the normal. If you need to write the parametric form, then just write, in place of y1 it will be 280, in place of y1 280 2a, and in case of x1 it will be 80 square. If we simplify this, you are going to get 1 xt plus 280 plus 80 cube, right? That is if we write if we change t to m, it will become t2 set minus m, that is it will become y equal to mx minus 2am minus am cube. That is, this part is the c part, y equals to mx plus m, and this part is the c part, that is c equals to minus 2am minus am cube. This is the parametric form, this is the slope form. Clear? And if the parabola is not passing through the origin, vertex is not at origin, then if it is hk, then it will be y minus k instead of y, and instead of it will be x minus h, and other things remains as it is. Clear? Now let us do some properties of normal. What are the properties of normal? If the normal is given, suppose let us consider this is the tangent and this is the normal. The normal is passing on the 2 points of the parabola, that is 81 square 281, 82 square 282. The equation we are going to get for that, please note it, it will be t2 equals to minus t1 minus 2 over t1. This is the condition, right? Clear? Now let us consider another part. Suppose another point on the parabola, let us coming from that fixed point is, let us consider this is another normal, right? Another normal, and this point is suppose a t, suppose this is a t3 square 2a t3, suppose 2a t3. Then what will be the relation between, suppose q and p? What will be the relation between Q and P. Clear? And that relation is very easy, that is T1 T3 equals to 2. How we are getting this? From the first property, there's this property, we can write T2 equals to minus T1 minus 2 over T1. And from the also from the first property, what we can write, suppose we need to write, suppose T2 equals to minus T3 minus 2 over T3. Clear? If we solve this, minus T1 minus 2 over T1 minus T3 minus 2 over T3, we are going to get a specific form, that is called T1 T3 equals to 2. This two part is very necessary for normal. Clear? And one interesting point I am going to discuss, that is what is the normal that is passing through the focus? Can you say the normal that is passing through the focus? The normal that is passing through focus. The normal that is passing through the focus is only the axis. Clear? Normal that passing through focus is only the axis, that is this axis, y axis, not the x axis. This is the normal, that is y equals to 0. This x axis will be y equals to 0, and this is the only normal that is passing through the focus. I think it is clear. Some part is clear, I guess. Now let us come to another part, that is conormal points. This is perhaps the last part of the parabola, I think. What is conormal point? Conormal point is very easy. That is when more than two normals intersect at a point. That is, suppose this is the point PHK. When the more than two normal, that is this is the normal, this is the normal, and suppose this is the normal. Tangent is this, this, and this. If it is written in the like this, M, N, and K, the point, if the more than two normals intersect at a point, then that point is known as, that M, N, and Q are known as conormal points. Clear? Now one thing, properties of conormal points. I am writing conormal points. What are the properties? First property is the algebraic sum of y coordinates of conormal points. Algebraic sum. Don't consider P as conormal. M, N, and Q are conormal. Clear? The algebraic sum of that y coordinate. That is y algebraic sum of the y coordinate of M, N, and Q. That is, if it is written in the form of, suppose am1 square minus 2am1 am2 square minus 2am2 am3 square minus 2am3, then the algebraic sum, that is y1 plus y2 plus y3 is always 0. Implies if we take minus 2a as common, we will get m1 plus m2 plus m3 equals to 0. That means this part a not equals to 0. That means m1 plus m2 plus m3 equals to 0. This is the first property, right? I hope it is clear. Now another question. The triangle formed by the conormal points, you can say it's centroid. The triangle, suppose I am just showing that let us consider. Okay, suppose this is a triangle, this uh, this 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 is the triangle, showing it in another part. This point and this point are conormal. If I draw a triangle, then the centroid will lie on the axis of the parabola, that will lie on the, that is centroid will be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and I have told that this algebraic sum of y coordinate is 0, then this is 0, then this is summation of x over 3, right? Then you can say this is lying on y equals to means x axis, that is the triangle formed by the conormal point, its centroid lies on the axis of the parabola. Clear? And the third point you are also going to get, that is if the point P, that is I have written P, that is suppose HK, if the condition H is greater than 2a, then the normal, those normals we have drawn, those are real, normals are real, as well as distinct. Clear? So the last part is equation of conormal point with respect to the parabola. That part I think that it is not required. I can discuss, but I have not seen in any question this part oftenly comes. But if it comes, then just memorize this part, or just memorize this part. The equation is this. This is k and this is 2, right? That is equation of circle passing through the conormal points. I am writing equation of the circle passing through conormal points. Now let us start part. I think the last part is chord of contact. I have not discussed. Okay, so what is the chord of contact? Chord of contact. The part chord of contact. Suppose we are drawing a pair of tangents. Suppose like this. No, not the pair of tangents. Just you can say the pair of tangents, and that line, this line is the chord of contact. If it is x1 y1 x2 y2 and this external point is hk, then what will, if the equation is this, then what will be the chord of contact? You know the equation of tangent is this. Chord of contact will also be same, that is instead of y1, instead of these points that is lying on the parabola, we have to write the point that is lying outside the parabola, that is the intersection point, that is yk 2a x plus h. This is the part, that is equation of chord of contact. Clear? Now this can we can also write in this manner, yk minus 2a into x plus h equals to 0. This is the tangent equation also. That is, if I draw this tangent, it is lying on that point, then it must be this will satisfy this part. That is, equation of chord of contact is t equals to 0. Simply t equals to 0. The next part is if the midpoint of that focal part if the midpoint of the chord is given, not the focal chord, not the chord is given, then what will be the equation of the chord? Suppose this is midpoint, so this is x1 y1, it's not midpoint, this is midpoint, suppose. Clear? Suppose this is midpoint, this is, then for midpoint given, the equation slightly changes. That is, it becomes t equals to s1. I have told you in circles in detail about this. The same thing you need to do here. That is, if t equals to s1, that means you are going to get like this. Clear? This is the final form. So I think this is the last part on the parabola. You need to go through different problems. You will get many more problems. You will get from focal chord, from I guess from the normal problems are common. Distance between normals, you will get the angle between the tangents. You need to practice. You need to first see the problems given in JEE books. First see the problems, understand it, and learn how to approach the problems, and after that go through the insight of that harder part. And if you can understand it, if you can do some problems on your own, that is the not the exercise problem, just the problems that are solved, first do that. Let's see that how far you are achieving your target, and after that go to the exercise part, increase your writing speed so that you can do more maths, more problems. Okay, that is up to you. You have to practice, and you have to understand how the approach, and I am there with you for if you face any difficulty. There is no problem. Thank you. I hope you have understood this one. The lecture is quite big, around 1 hour 10 minutes, so let's have patience over the lecture and try to see it after having a 15 minutes break or 20 minutes break. That would refresh your mind and you will understand more easily then. Okay, thank you.